Good day to everyone. So for today, we are going to discuss the exploratory data analysis or the EDA using R programming. So what is exploratory data analysis? It is refers to the critical process of performing initial investigations on data so as to discover patterns, spot anomalies, to test hypotheses, and to check assumption that eventually help of summary statistics and graphical representations. So we have here a graph showing the process on how are we going to conduct exploratory data analysis. So first things first is we need to load the data, and after loading the data, it will goes to the step one, which is the identifying the attributes, and then it will move to the step two and step three, which is identifying or the analysis of univariate or multivariate. So in this particular step, uh, you are going to analyze the given variables. And for the step 4, which is the detection of aberrant and missing values, whereas the cleaning of data is conducted, which can lead to the step 5 of identifying the outliers. And step 6, feature engineering, and the last step, it will show us some business insights based on our analysis that we have conducted. So we are going to further discuss all of those steps in the succeeding modules. Alright, so before we further discuss the EDA, okay, so it is important to understand the following key terms. First is we have the value. So what is a value? A value, this is a single piece of information, and it can be numeric, categorical, or temporal. So for example, it includes the, for example, in a numeric, we have the number 42, 3.14, -10. So those are a certain kind of value. Okay. We can consider also yung mga categorical value natin. Like for example, if you are referring to the color, that is red, the blue, and the green, and so on. Alright, next we have here the variable. When we say about data variable, it is the characteristics that can take different values. Okay, or this is the characteristics that you can measure, such as weight or income. So variables can be independent or dependent. Independent variables are inputs or predictors, while dependent variables are outputs or responses. Example of this, let's say in independent variable, those are the age, the temperature, our hours of study, and so on. While when we say about dependent variables, those are the sales revenue, exam score, house prices, and so on. Alright, next we have here the distribution. When we say about distribution, this is how the data set is spread out. Okay, so spread out or distributed across different ranges. So basically, it provides insight into a central tendency, variability, and the shape of the data. Okay, so in distribution, we have different types of distribution. It may includes normal distribution, uniform distribution, skewed, and also the bimodal distribution. So, ayan. For example, dun sa uniform distribution, it's just as simple as all values have equal probability. So, ayan. Anyway, we can, you are going to encounter these different types. Okay, so erase those parts. Coming up next, we have here the outlier. Alright, so when we say about outlier, this is a data value that significantly different, including much higher or lower from the rest of the data set. Now, when we say about outlier, it can occur due to the errors in data collection, or in natural variation or rare events also. It can also occur. So, for example, uh, example of the outlier, in a data set of exam score ranging, for example, of 0 to 100, and eventually some of the data has a score of 1,000. So, that is the outlier. Ano pa? For example, in a data set of household incomes, a value much higher or lower than the typical income range. For example, ito yung mga sumusobra doon sa siniset natin na mga range doon sa ating particular data. That is outlier. Next, we have here a data model. So a data model is a method of organizing data and the relationship between values in a data set. So basically, data model helps to organize and structure data for efficient storage, retrieval, and manipulation. Alright, so we also have a lot of data model, and some of this is yung relational model wherein you can organize data into tables with rows and columns and link by keys. And we also have entity relationship model, okay, wherein the data is represented by entities, their attributes, and the relationship between them. So those are the following key terms that we need to familiar while we are conducting EDA. All right. So next is know your data or knowing your data. Okay, so the first step to conduct exploratory data analysis is to observe your data set at a high level. Okay, so it will start by determining the size of your data set, including how many rows and columns, and this can help you to predict any future issues you might have with your data. So it is very important before you conduct the ADA. Okay, you need to first to identify the structure or how your data is structured. No? Ilang observation ba meron dito? Ilang variables ba yung meron dito? Something like that. And you also check whether is there something like missing on the data. No? So yun. Okay, that is the first step that we need to consider before you conduct the EDA. Alright, so let's do some hands-on, and we're going to work with a simple EDA using the IRIS dataset. So now I am going to open my RStudio, and okay, let us discuss or let us try to conduct EDA using the IRIS dataset. So the IRIS dataset in R is a built-in dataset that contains measurement of 4 different attributes for 40 flowers from the 3 different species. Okay, so the ano to no, yung IRIS dataset is default siya na dataset sa R language dito sa RStudio. Okay, basically itong IRIS dataset na to ay dataset ng tatlong magkakaibang flowers. Okay, so first things first, since this IRIS dataset is a built-in in R, so we are just going to call that dataset. So paano ito siya gagawin? We simply use the keyword data and followed by the IRIS. So ganyan lang siya, and we can now run this program. And ayan na. So, dito sa ating environment, lumabas yung ating IRIS. Okay, meaning to say, we already have loaded yung ating dataset. And now we're going to explore on, or we are going to look how the IRIS dataset is structured. Ito yung sinasabi natin kanina. Before you will do the conduct, or you will conduct the EDA, you need first to know your data. So we can simply identify or know our data by viewing the structure of it. So paano? How we can view the structure of our dataset that we have loaded. So ayan, This is the keyword, no, that we are going to use. We use the str and then followed by yung ating dataset na iris. So basically that is str stands for the structure. So str shows the structure, okay, indicating the observation and the variable as well as its data type. So try natin i-run itong program ito or itong statement na to. str iris, and if we hit enter, ayun, as you can see dito sa ating console, ayan, so lumabas dito yung ating iris daw ay isang uri ng data frame. Now when we say about data frame, again, that is table, no, that is data types na referring to a table, and yung ating data frame daw is composed of 150 observation and also 5 variables. So all in all, there are 150 rows of record in iris dataset with 5 columns. So check natin, no? Iris dataset is already uploaded or is already loaded in our RStudio, and as you can see here, 150 observation of 5 variables. So if you click this this table, okay, it will display, ayun, sa ating table yung ating iris dataset. So tama ba? Ilang column daw or ilang variable? Now when we say about variables dito sa ating R, it is referring to the number of columns. Sabi dito 5 variables. So let us count. Mag-start siya syempre dito sa sepal.length. So 1 followed by sepal width, 2, 3, 4, and 5. So fifth column is we have the species. Now if we are going to check the species or the species variable, it has a data type of factor. Okay, ayun, no, porositosa, and then if you are scroll down, next is the versicolor, and followed by the virginica. So those are the 3 different flowers included in our iris dataset. Okay, so ayun. Next, how about if we are going to check the dimension of our iris dataset? Although we already know, no, every time that we are going to load a data kasi in our RStudio, it will display already the dimension. Sabi dito 150 observations of 5 variables. So ano pala ibig sabihin ng observations, no? As we can see here, ito yung number of rows. So technically 5 variables is referring to column, and observation is referring to the rows. So 150 of 5 variables, and if we are going to look at our table again, so we already know that it composed of 5 columns, and if we're going to scroll down, it has, okay, so it has 150 na rows. So that is the observation. Now to verify, okay, so let us going to check the dimension of our iris. So the keyword is dim for dimension, and let's say iris, dim iris. Run natin, and it shows that it has 150 and 5. So that is the dimension. Okay, so next, how about if you want to identify or to know the names, okay, of every variables or the names of the columns? So we can do that by simply typing names followed by the iris. So that is names and iris. Highlight natin, click and run, and sabi dito, okay, angat natin. So sepal.length, ito yung first column natin, followed by sepal.width, petal.length, petal.width, and yung species. So check natin, tama ba? So sepal length, sepal width, okay, petal length, and petal width, and species. So tama, no? So in a flower, when we say about sepal, ito yung outer na bumabalot do sa flower, no? While yung petal, yun yung mismong flower natin or flower. Okay? So anyway, that is how we basically check the names of our variable. Okay, and let's say if you want to take a glimpse of the first 4 lines of the rows, okay, let's say going back to our table, and I only want to check yung first 4 observation. Ibig sabihin, from here hanggang doon kay row 4, hanggang dito, no? So, how can we do that? I want to display only 4 observation. So, we can do that by simply, from here, we are going to type head, okay? And followed by iris, and since I want to display only 4, so lagyan natin dyan is 4. So head is referring to the head of the table, meaning to say yung first yung mga nasa rows located at the top, very top of the table. So that is head. That is okay, the code. And try to run this program, this statement, and it says that okay, it only display yung ating first 4 rows. So, okay, nag-start siya kay 5.1 and nag-end kay 4.6. Let us check kung tama. Nag-start kay 5.1, nag-end kay 4.6. So, tama na. So, that is how we check the first 4 lines of the row. Siyempre, it depends, no, on the number that you have selected here. Let's say I want to display yung first 10 of the rows from that table, and run natin. Of course, it will shows the first 10 rows. So how about yung the end, or yung mga nasa dulong bahagi ng table natin? So of course, if we have a head, meron din tayong tail. So tail is basically it will allows you to check the last 6 record in our data frame. So tail, iris, and yung last 6 last 6 data in our table. So run natin, and it shows that ayun, nag-start siya kay 145 hanggang kay 150. Bilangan natin 1, 2, 3, 4, 5, and 6. Again, if we are going to check, if we are going to use tail, it means that it will display the last 6 records in our data frame. Okay, so that is the tail. Alright, next is, how about if we're going to check the summary of our data frame? So from here, let us check the summary by simply typing summary, and followed by of course, our dataset, iris. Okay, highlight natin, and click natin yung run, and sabi dito, okay, ganito yung magpapakita. Now, sabi ko nga, sabi ko before that, itong ginagawa natin is just exploratory data analysis, meaning to say, we are just describing the data. And again, if we are going to use descriptive analytics, there are certain tools that we can use, such as yung mean, median, and mode. No? First, it has under daw ng sepal.length, it has a mean, or that is the minimum, of 4.300. And we have also here the first Q, or the first quartile, no? And also the median, the mean, third quartile, and then the max. So, ganun din dito sa sepal.width, the petal.length, petal.width, and also sa species, iba yung magpapakita dito. So, mamaya explain natin bakit ganito yung nagpapakita sa species. Now, isa-isahin natin. First, we have here the mean, or stands for minimum. Now, if we are going to check our yung first variable natin, we have the sepal.length. Ang minimum na value daw doon is 4.300. How about yung first Q? So, or yung first quartile. So, the first Q value is 5.100 for sepal length variable in the iris dataset. So, it indicates that the first quartile of sepal lengths in the dataset is 5.100 units. Now, when you see the first quartile value is 5.100, okay, it means that approximately 25% of the sepal length measurements in the iris datasets are below 5.100. So, dito kasi no sa ating data, we have 4 quartile. Okay, yung first, second, third, and yung fourth. And every quartile is divided yan by 25%. Meaning to say, first quartile is 25% and followed by second quartile 50, the third quartile 75, and obviously yung fourth is yung 100%. So this value is derived, so yung 5,100 yan na output niya doon sa sepal length derived from the distribution of sepal lengths in the dataset and can provide insights into the range of spread of sepal length among the iris flower included in the dataset. Meaning to say that sabi ko nga no, 25%. Ibig sabihin 25% daw dito sa ating data frame na iris has a value of below approximately lang to no, approximately 25%, yung merong value na 5.100 and below has 25 is 25%. Now, doon naman sa ating third quartile, and if we're going to check here, that is 6.400. It means that based on our data set doon sa ating data frame na iris, so ibig sabihin, since this is third quartile, meaning to say that is 75%. So 75% daw ng sepal.length ay mayroong value na 6.400 and below. So that is the quartile means. Alright? And then again, we also have here median. So ano naman yung median? Under ng sepal.length, we have a median of 5.800 for the sepal.length. So it means that, or in other words, so the median is it divides the data into halves, where approximately 50% of the sepal length measure are below 5.800 units and other 50% are above 5.800 units. Okay? So that is the median. Or sa madaling salita, ano ba yung median? No? Ito yung gitna. Okay? So first is you need to sort your data, okay, from minimum to maximum, or the ascending order, and the median is yung middle part, no, or yung the 50%. Okay, how about yung mean? So the mean value of 5.843 for the sepal length variable in our dataset represent the average sepal length across all observation in our dataset. Okay, so the mean is calculated by summing up all the sepal length values and then dividing the sum by the total number of the observation. So sa madaling salita, ito yung average, no? Average nung first observation natin, which is yung sepal length. So it also applied for the sepal width, petal length, and petal width, since those observation are in numerical. Okay? That is why doon sa species na observation, ganito lang yung nagpapakita, no? Setosa, it has 50 observation, and from the versicolor, it also 50 observation, and virginica is also 50 observation. So bakit if you are going to notice, no, why is it doon sa species is hindi nagpapakita yung mga minimum, first quartile, median, and so on? So meaning to say, because this species, if you're going to look our species data frame, hindi naman siya numerical, no? Character siya. Okay? So, and if you're going to browse, yung character na yan is parang parang nauulit-ulit lang siya for the entire column, no? Or I mean for the entire table. So that is why it will fall under the categorical data type. So, hindi siya sa numerical but to the categorical. Kasi, if we're going to notice here, it only composed of 3 different flowers. Yun ang sinasabi natin na setosa, versicolor, and virginica. So, that is why, yung nag-conduct tayo ng summary, it shows that ito lang yung nagpapakita. Because the species observation or the species variable is not numerical but rather by categorical. Alright? So, that is all about for the summary. Okay? So, how about if we want to visualize the iris dataset? So, we already know for us to be able to visualize a certain dataset, we can use the plot. No? So, from here, let's say plot and yun pa rin, we have also the iris dataset. And if we hit run, and ayun, it will display on the right side, okay, dito sa ating plot. So, ayun, ito yung visualization ng iris dataset. Okay? So, of course, we cannot identify it yet. We cannot basically state what is this graph means, no? But anyway, I am just presenting on how are we going to display using a plot yung ating iris dataset. Alright, so coming up next, how about if we want to check the quantitative variable on our iris dataset? Okay, so I am referring to the quantitative, meaning to say, alin ba yung quantitative dito na value? So, 4 lang yan, no? The length, the sepal length, width, hanggang kay petal width. And let's say, I want to plot only the sepal length. Okay, I want to plot the quantitative variable. Let's say, yung sepal length. So, paano? Again, we can use the plot and let's say iris dataset, and followed by $sign, and we have the sepal length. So, ibig sabihin, no, from iris dataset, I will going to choose only the sepal length. So, that is the $sign is referring about. Okay, and yeah, from here, I can hit the run. Okay, and then there you go. So, this particular graph here is only referring to the sepal length in our iris dataset. So, ayan, mas clear na yung ating graph here. Alright, and that is how we can identify, no, or knowing your data before the conduct of exploratory data analysis. So, yeah, that is how we explore or work EDA with our iris dataset. And next, we're going to utilize here the H-flights dataset.